G'day guys, it's Calvin from the Cartoon Company. So this is number 2 in my video of wiring stuff-ups for 1UZs. We do have one small problem today. There's a man over here working on a Subaru motor and he has a rattle gun. So at every opportune moment there may be a rattle gun noise. That one. So I will have to repeat the odd thing. Anyway, I got this loom from a customer. It's another garage. They're working on a Daimler and it's got a 1UZ in it. They were delivered it, they were dropped it off. They have to fix the stuff up that is this 1UZ fitted in a Daimler. They sent the wiring loom down to me to fix. I gave them a little bit of a hand on a few things and they went, stuff it, we'll take it off and send it to you and you can fix it. So I've received it. So let's have a look over this loom and see how bad it really is. So this part of the loom doesn't look too bad. It looks like a second-hand 20 series loom. Still got the traction control in there. Still got the extra butterfly, the extra TPS. So that'll be coming out. The water temp sensor for the gauge has been changed and had a fan switch put in. So I traced that wire through with an extra earth added. Comes over to this plug and disappears off in a wire. This one, that's marked to the fan relay. That's fairly straightforward. I don't know where the temp gauge is on this vehicle. It's had the alternator wiring added with this plug. It's had the alternator wiring added with this plug. And this wire, which is probably good for maybe 60 amps on a 100 amp alternator, pops out of the loom over here. So that'll go and be changed. But that side of things isn't too bad. The main issues come when we get to this bit here. So here's the 28 pin plug. This vehicle is an auto. There's 4 wires connected. It's not enough for an auto. These two are joined together, which is wrong. The main battery power, I thought, hey, they might have got that right, but it's joined to these two on the other side of that plug. The main relay output is being used for a positive feed for the starter relay. This wire here is part of the start inhibit, which is an earth. Runs down to this plug. They're meant to be a positive because it's meant to feed positive to the ECU so it fires the fuel pump. So that triggers the fuel pump. This is your check light, not connected. So there's a whole lot of it's just a rat's nest. There's a whole lot of wires. This plug's been attacked, but none of those wires that have been removed, if they're not used, they're just cut off in the loom. Those are gear indicators. All those are just hanging out. Here's a plug that has all the earths, all the shield earths, and there's normally a joiner on top. That's not there. Good news, he does have the right igniter. The customer felt that the airflow meter, or the garage thought the airflow meter wasn't quite right. And you'll see this one was one I did the airflow meter video on. The correct airflow meter for the job. And it did have an airflow meter problem. So if we go over to the airflow meter plug, that's there. There's a big white wire, as in the airflow meter video. Should have power. Comes over to that one. There it is there. It's not connected. So the airflow meter wasn't working. This is the fuel pump wiring. And I think they must have been really worried about fuel pump wiring because that is kind of grunty. It's pretty big. Relay box. So this must have been an ignition input. So just ignition power. So that circuit's all wrong. All the powering up for the ECU is wrong. So that wouldn't work properly. This one here, that's your fan. Off to the fan relay. So we're going to improve that, and I'm going to put it into this relay box here. So basically, it's a giant stuff-up, and that's me being polite. So the plan on this one, it's pretty easy. well, pretty straightforward for me. I do a lot of them. Standard job on the wiring on the engine bay side. I think I might go over and put a bit of braided sleeving on this one. The owner has spent a lot of money on it. He wants it to look good, so let's make it look good. And then tidy up around that computer and make it look reasonable there as well, and bring it into line. I'm not going to show every detail of this one. The main engine wiring job is going to be very similar to my 20 series wiring instructions. And so I'll do that process. We'll just do a few little tips on that, little bits. And we'll see what the end result is. I do have another small issue, pressing issue, which happens to be this engine here. So this engine we got out the other day. It's had a prep job. It wasn't in a state where we could do a compression check originally. We put a compression gauge up it. It's a little bit lower than I'd like. So we're going to kill two birds with one stone. I'm going to wire this loom, make that motor go, confirm that motor's good, confirm that loom's good. So I can put this in a box to go back to its customer, and I can put that one into a Hilux. So wish me some luck. No, I don't need luck. I've got this. I'm not going to attempt to it blindfolded, but we're going to get into it, sort this out. We'll give you an update once we've got a bit more done. Bit of an update on this loom for the Daimler. I've done down the right hand side of the engine. So I've had all this apart, popped the plastic cover off, gone through, I've ditched all the tape on this one, and we've put braided sleeve all the way through. I've also changed some connectors. So as soon as I touched these connectors inside, the little locking tabs were falling apart. That's the idle speed. The coil one, the locking tab fell off. The injectors weren't too bad, but they're starting to get big cracks along all the locking tabs where they squeeze. So I've changed all those. The temp sensor had the broken locking tab, but it also had, if we can get it nice and close, cracks on the wires just by the plug, by the connector. So I cut it off further back, put a new section of wire on. Also removed the traction control. I've got my box of rubbish here. Traction control plug gone, and that can actually be used, recycled for the idle speed control units if you want it. They're generally in pretty good order. Traction control plug, and the sub TPS that's in there as well, that's gone and been wired as a non-traction control vehicle. I'd also had the temperature or a fan switch on this side through the temperature sensor wire, but I've re-added the temperature sensor wire, so if they want to put a temp gauge they can, and I'll put the fan switch on that side. I've gone right through the igniter plugs, checked all them, again a little bit of braid on them. Out to the airflow meter, same deal. Earth, that's been tidied up, and down to the gearboxes being all taped up. And this one I'm using a cloth braid. It's a super sticky quality cloth braid tape. So with regards with changing connectors, I don't see much point running old connectors, or these are prone for brittle connectors. And I see guys that they don't want to touch their loom because the connectors are brittle. It's a far better idea to remove the connector and change it to eliminate that chance of them breaking and giving reliability problems. I see quite a few vehicles come in, they're not starting, and they start, they'll fire into life and then instantly stop. And it's because of a coil connector, and the coil connector is not on properly. The computer shuts down because it doesn't get the feedback, and it stops for the sake of a couple of connectors. So I buy my connectors like this, by the bag full. So that's injector connectors there. My bag of connectors that came in last week. Idle speed controls, throttle and oxygen sensor, temperature sensor, that's how many of them I do a lot of those. igniters, coil, oh no, cam angle sensors. There's a heap of connectors in there. And some throttle body barbs. So now I've done the right hand side, time to go down the left hand side and modify the diagnostic box as well. So I'm part way there and it's coming along quite well, no real big issues. So I'll give you another update once this other side's done and we get into the ECU wiring. Work has been progressing well on this Daimler UCF20 loom. I fitted the loom up to an engine just to make it all, check it's all right. And I am going to be testing this motor as well and running this loom. I sized up the fan switch wiring. So that comes out quite nicely. Plugged it all together. It all plugs into the standard front loom. And I've already gone through the front loom on this one. It's going into a different Hilux. And I've cut off the hydraulic fan wiring. So if we want to run the oil pressure through the loom, those are the wires that get used for that. Diagnostic box has been modified and fitted. And we are using the breather for the fuel tank on this one. I've put it in. Even if it's not used, the plug can just be popped away. That loom's looking quite nice with the braid sitting on the engine. Pretty happy with the way it's come up. And I have to run the alternator wiring yet, so that's why I sort of sized it up on the engine as well. So I want to make nice alternator wiring. And get into this side of things. So that's going to be a whole lot of fun. That's my job for the moment. Try and make some sense of this mess here. When you're working on a repair job, you find lots of interesting stuff, like the twist. And it probably did have tape on it, just the twist joint. So we might fix that properly. The funny lengths. That's great. This is normally got a joiner on it with all the earths, and it's not. So there was an earthing problem in here. Oh look, here's another something. I'm not sure what that is. I'm going to have to research what's going on in there. There's another twist. This plug, if you remember before, had a whole heap of wires coming out of it. I've solved that problem by just taking them out. So instead of joining on the back of each of these, I'm going to crimp and push new wires in. So the goal at the moment is to go the rubbish, work my way through this and actually make it look like a wiring loom. And try to make sure that I find every one of the idiot factors that have been done in here, which isn't always the most fun, but just got to be thorough and I'll get there. We're starting to see some form. You can see it's not so much of a bird's nest. I've taken the joiner out for the earths, so that can be taped in nicely. I've got wires coming up for the diagnostic plug. I've got wires coming out. Oh, that's dash. Yes, that's dash wiring. And these ones, I wasn't sure what to do with these ones. They're the gear indicators, which that one is the reverse, the black, red. No, red, black is reverse, and the green ones are for all the gear indicators. They come down to the selector switch. So I'm just going to pop them on a plug. If the man wants to use reverse lights, he can. I don't really want to take them all out or leave them staggered in the loom. I'm better to put them in a plug, I think. And then we've got our power feed wires over here. Some of the factory joins for Toyota. And a lot of them, where I can and I've been able to get to, I take the tape off and I heat shrink. Can't get all of them, but that makes it a lot better. And I've got this big abortion of joins done by the last person that wired it, and I'm not really happy with that. So I'll make a couple of changes in here soon. That'll be my next job. It's actually kind of looking reasonable now, and we can move forward. So the main part of the ECU connections is all done. New crimps straight into there, so there's no joins in the wires that run up out to here, and some run out to the diagnostic plug. There's the adapter for the under bonnet, under dash connector. So that's the one that I keep for myself. but I have modified that connector as well. These are the gear shifter. There's some for the dash, so we've got a tacho output, check engine light, water temp, and oil, which is the modified hydraulic fan wiring. Got rid of that earth piece that was poking out, that's been taped in. The loom comes up, and I've got the last piece of this loom to do, even though it's ready to start just about. Got the igniters attached and the airflow meter attached and a throttle body. But I need to put the alternator wiring through, so I've got some big grunty cable because it was quite pathetic and small. So we're going to run that through this grommet up, and I'm going to run it along the back next to the loom. I'm not a fan of the alternator wiring being in there. I try to avoid it if I can, especially on a standard computer. Some of the aftermarket ones, they don't seem to suffer the interference quite the same, or they're just different. So I'm going to run that in. On this motor, I actually managed to get some new emission hoses, so the PCV valve hose and the breather hose, both brand new on this engine, which I'm really happy that I've got them now. And I better blank off the booster line. And then I just need to wait to put the plug, the connector onto those ones, which will go to the relays and fuses. And I'm ready to make that fuse box. I'll have a bit of a tidy up on my bench. I'm pretty happy with the result of that ECU. It's looking pretty good. It actually resembles a loom now, not a bird's nest. Another part of these looms that is really important is oxygen sensors, and I'm seeing more and more failed these days. I'll be supplying some new ones with this loom and this engine as well, which is going into a different truck. That's getting new oxygen sensors as well. And I'm running genuine Nippon Denso sensors. The relays and fuses, I'm going to go with these blocks here. It's going to be quite bulky, but it'll do the job that I want it to do, because I do plan to run some extra fuses for the input for the overdrive, the brake lights, the park lights, or the electrical load signal, and the power economy switch. I've run extra wires and fuses for those, as well as the normal ones for the relays and fuses. You'll notice I've dropped the size of the wiring down there. There's a couple of joins in here, it's down to single size wires, so it's a lot smaller in that loom than it was. Just as I'm tidying up, or before I tidy up, just thought I'd change the starter trigger plug. And I started in there and it just started to completely disintegrate. The plastic's just so brittle. I see a number of these that have starter issues, and sometimes this plug's fallen to pieces, just not making good contact anymore. So a new one, when I'm doing a loom, it's pretty much always a must. And knock sensor plugs are the same. They fall to pieces. So a new one is a great idea. I've put in the alternator wiring, and I've run it along the back, through some heat proofing through there, and down under here with the boot on it, and it plugs in again with heat proof, and that completes the engine loom. And I've started working on the fuse box assembly, so it's going to look like this one. Because this one is auto, I'm putting in a start relay, and there's a fan relay which is coming into here. This is a little bit bigger than some others that I do. I think it looks a bit neater and tidier. And I'm making it with Tefsel, so the wiring is quite small, be quite compact, coming out to the plugs, and I've run Deutsch plugs going onto the engine loom. This one I've put the alternator wiring separate, because that was separate in the vehicle, but I'm also putting it through the fuse box as well, so the garage that are fitting it up have got some choices. So I'm getting to the pointy end of the stick on the Jaguar Daimler UCF20 job. relay box has just been completed. Well, I hope I've completed it. It's at the time when I get my test light out and I check over everything. So let's have a look at what I've done. Comes through on the main loom. It comes to this set of plugs here, and that unplugs really quickly. There's a few plugs that go off to the dash, so check engine light, water temp, tacho, oil pressure, and then gear indicators, which are probably just going to be tied in, probably not going to be used. Though if the garage finishing the job wants to put in reverse, they can, it's in there. I've got this diagnostic plug, which is kind of handy. And then this stuff plugs into the fuse box. The alternator was run separately. It had its own wiring coming in from somewhere else. So what I did there is I put it on a plug. I've tapped in alternator stuff in here, but this could be wired separately and that could just be left not being used. Trying to make it as universal as I can in this particular job. I've numbered up these plugs, so a 12-pin Deutsch plug. So there's 12 wires in there, and an 8-pin with one missing. There's 7 pins in there, and a start trigger in that one. So there's quite a lot of wires coming out of the loom. Comes into where the relays and fuses are, and that happens. Stuff happens there. To actually make it run, now it needs main battery power, ignition switch, and the start input. And that should make it go, along with some fuel. So that's the fuel pump output there. I probably should mark that. Fuel. So the white one is the fuel and a blue one is the fan. Funnily enough, blue for water. I've got my test light and we're going to go through, lights up. I'm going to go through and check where power should and shouldn't be. There should be power there. There's a little bit of stuff stuck in that one. And most of the bottom of the fuse box is in Tefsil mil-spec wire. I'll flick that over and it's powered up. So that's what it looks like underneath. So not a complete bird's nest. So going through, where I should have power is there, this one, there. This is ignition input. Oh, it's over here is ignition. So that's going to need a fuse. And I go through every circuit like this, double checking that it's all good. So there's a little bit of work involved doing that, at which point I'll actually make it run. Bat next to that. So as I drop the fuses in, I'm testing all the circuits. Also got a shifter set up so I can put it into a park and I can check that the computer sees the gear indicators. And I've got a fuse block here. This is for the alternator fuse and the main power into my relays and fuse boxes. So I'm going to get that done and I'll come back to you when we're just about ready to make it run. So there's a little bit of a haze in the workshop. I was doing some testing of the fuel pump circuit, which is in front of me. I've got all the relays in. There's 4 fuses I haven't checked yet. I went like this. It runs surprisingly well considering there's no actual petrol in it. This motor had been sitting for a long time. Well, an unknown amount of time. It came here in a black Hilux, which I'm going to be doing a conversion on, a 2003. We did a compression test on it. It didn't have a sump on it. We'd already cranked up oil pressure, done all that sort of stuff. And when we did the compression test, it was a bit low. And I see this all the time. Things like the back bell housing bolts were just absolutely full of dirt. Looks like I've been sitting on a dirt floor. So I'm making it go on this job. Because it was a bit low and it had been sitting, I did put some oil down the bores, put a couple of squirts from the oil can. So I'm not concerned about the clouds of smoke at the moment. But the fact that it runs is a really good sign for me. So we will be giving it a bit of a run up, and I'll be doing another compression test on it. But I needed a motor to run for this job, and it happened to be a 20 series. I think some petrol's in order. Set up the petrol can. It looks like the relays and fuse box is working like it should because the engine runs. So far it's all tested good. I'd missed one earth. Big deal. Took me a couple of minutes to put an earth in. So a few things about my relay box. What I've done in this one, a little bit different, I've run some of the external signals like the brake lights and the electrical load for the lights through this fuse box. They're possibly going to be tapped into the rest of the vehicle, and they may not be fused, so this will give an extra bit of protection before it goes to the ECU instead of going straight into that ECU. Done the extra relay, extra fuse box for the main power feed into this, and it might be changed when it goes into the vehicle. Do have to allow for things being changed. Put the nicer relay fuse box on it. So I think it's time for me to get some petrol, set up the bucket of noise, put the petrol on, blank up a few vacuum holes on the engine, and we'll make it run proper. And then I'll do a short instruction video, which I'm going to tack at the end of this video for the customer to look over. They are a garage. Now, just a few notes that this wiring job, like, it was ugly, really bad. It was done by a garage or a auto sparky of some sort. It was done by a professional. The garage that's got it is going through some major sort outs, and they've been ringing me, asking me some questions. I've been helping them out as much as I can. During this job, they did tell me they're taking the motor out because the chassis needs to be plated. So it's a fairly major job and a big stuff up. I'm 3 days deep in this job, going through making sure it is 100%, double checking it, triple checking it, because I want it to be right. I don't always fire my motors up on my wiring jobs up, but this case it was worth doing it. The idiot factor in the loom was quite massive. The person that had attacked it had made an absolute abortion of the job. So I do have to factor that into my time because I become responsible for it. That's why I prefer to do virgin looms, and that's why I didn't do a full wiring video. I'm due to do one on an auto UCF20, but I'm not going to do it on a loom that's not a virgin, because most people won't see an abortion like this. Hopefully they'll get a nice loom that hasn't been touched and fix it from there. So petrol time, make it some noise, and then I'm going for a four-wheel drive. We have the petrol. I'm happy about that. I'll just show you something though. When you feed your start signal in, start again. With a Toyota, when we power this up, the fuel pump doesn't prime, okay? There's no prime function in the middle. But when you give it a start signal, so I've disconnected the start trigger. So the start trigger is this plug at the back going to the starter motor. When I give it a start signal, maybe I should put my test light in. I've lost my test light. That's fine. Here we go. So here's fuel pump. When I give it a prime, when I send the start signal into the ECU, the fuel pump goes. So no prime function, but it does go on crank. And it needs the STA signal correctly wired into that ECU. And then we've got the fuel pressure dampener here. So this is the inlet. Cut the barb off and we'll prime up that fuel. And the little screw pops up when it's got fuel pressure. Vroom, it goes. Woo. She runs, and actually runs pretty good. Smoke's dropping off. That motor's sounding pretty healthy, so I'm happy about that. Let's see if we can communicate with this vehicle, with this computer, with the scan tool. I'm starting today by connecting into the engine diagnostic box. Now I have modified this. This is a UCF20. It is missing 2 pins to make it work in normal situations. So I have modified that to plug a scan tool in. Normally you cannot plug in and get data out of a UCF20. The other thing you do need for it to read codes is a check engine light. So I'm going to give it a check engine light. And here I've got check engine light. And you'll see it's flashing, so we can tell that we have connected in. And it's flashing a code. Not ideal. Might give me something to do. Might be code 56, so code 56 isn't a problem. I'm looking at the scan tool if you want to count the codes for me and let me know what it is. It's not a Nissan. Let's try that again. So with the flashes, fast ones and slow ones. So slow are 10s. And then fast ones are 1s. And I haven't been counting it. That's quite a few there. Yeah, that's got to be code 56, which isn't a problem on a UCF20. If you've got a code 56 on a UCF10, then it's likely you're going to have a running issue. Right, we're in with the scan tool. I'm pretty sure that was a code 56. Don't give me that shit. It's telling me it doesn't have any trouble codes. Let's try that again. It's been a long day. Let's try that again. So we're going to put a check engine light back into it. So check engine, I've given it power and into there, into the W terminal. The reason it wasn't working is I went in as an LS400. And an LS400 in 95, 96, you can't communicate with the one on the engine. So the scan tool was saying you can't communicate with the one on the engine. So what I have to do, my scan tool has the ability to say other. So I go in as an other, as a rectangular connector, and then as engine control. And it just goes into a generic type program. And now it will read codes, and it is. So you can't go in as an LS400, you go in as an other. And you can do it under Toyota as well, on this scan tool. And it is reading my check codes. And it is going to tell me code 56, just to match what I counted. Cooling fan pressure switch. So that's not a problem on a UCF20. Going into the live data, and it goes in just fine. We've got idle air control, we've got temperature as a voltage. We don't want to get it too hot because we don't have a cooling system. Idle signal is on. We'll just check that throttle position sensor. And as soon as I lift it over, it goes off. The park neutral switch is important to check. So at the moment, it is saying that the park neutral switch is on. And I'll just move it round. So I'm moving the shifter, turns off. It's on there and off. There's got to be another one in here. There's got to be on. There it is. So there's neutral right there. Starter signal is off. So we know that starter signal works because the fuel pump primes. So I don't actually need to check that on the scan tool. So all that is working like I'd expect it to. I'm going to change it now. We're going to pop out of that one and go into the proper one. So by modifying the one on the engine, it means that any workshop with a scan tool can plug in. Because most jobs I don't get supplied with the 17 pin, I think it is semicircle. But I modify it for my own use. Plug my own adapter in. And this one doesn't have a power supply in it. So you have to add a power supply as well. So this time I can go in as an LS400. Again, as soon as I've plugged in, the test light is flashing, which is my check light, of course. And you need a test light, or you need a check light, because the scan tool is really primitive, and it's just counting those flashes. Nothing flash about that, it's just nothing technical, it just counts the actual pulses. And this time I'm going in as a UCF20 with oxygen sensors. Again, I just check that it does communicate. It is doing that. And we'll have a look at the current data. And this data is very similar, but it's got a temperature. So it tells me proper temperatures. It's got, instead of park neutral switch on off, it's got R2, RD2L, and then it's got park neutral if I put it into park neutral. So it's slightly different in the data, but still very helpful. And I'm just wondering if I can get transmission info out of this one. So having a scan tool, being able to attach the scan tool makes a big difference when diagnosing and to set up properly. I like it with the autos to check that the park neutral switch is set up properly and all those sorts of things. So it's a big help. So the next one I will do, well, pretty soon I'll be lifting this loom off, and I'll probably include that in this video. But at the very end, I am going to do a set of instructions for the customer, the garage who are fixing this, putting it all together, of how to put it all together. So that might not be relevant to everybody that's watching, but hey, there might be some tips in it to see how the loom goes on or off. So I've also just tried going into the information for the transmission. It's got quite different in this one. It's not connected into the overdrive circuit. It's got its own output from the ECU. So I've wired that into my scan tool. Again, popped it in as a test light. And it is actually bringing up codes, which is really cool. It's told me that the lockup control solenoid isn't working. It's bringing up the accumulator control solenoid isn't working. I bet you it's going to bring up solenoid number 1 and solenoid number 2 as well for that transmission. On number 1 shift control solenoid. My scan tool's getting old, so the screen's a bit funny. Let's see if it brings up number 2, which is like 63, code 63, I think. There's code 63's just come up. That's good. And I think we need a speed sensor. We're going to have a speed sensor code as well or not? No, because it hasn't been put into gear. So it doesn't bring up a speed sensor. So that's really positive. It's brought up transmission code. So that's, again, if a diagnostic light is wide, but there it is there. And that's probably because there's the transmission plug. So the computer has picked up that no transmission is attached. So that is very, very positive. I think that's great. So I'm really happy about that as well. My UCF20 to Daimler loom is now complete. I'm going to show you the one other test, and I know this is a repeat. The biggest wiring mistake I see on UZs, and they should hold the power onto them when the keys turn off. This loom, when I started, was never going to do it. It was never going to idle properly. Things were never going to run right. What I'm going to do, we'll show you now. We connect up the ignition power, like so. Power's up, and we have light shining through the door. We have the test light on. We start the engine. And when we turn it off, the power stays on for a few seconds. So that's correct, that's how it should be. So if you do that test and your UZ fails, it's not wired right. So that's a wrap for the main part of this video. If you enjoyed it, hit the like button. If you're doing lots of 1UZ stuff, subscribe to my channel for lots more. And I'm going to flick over and do the instructions for the customer now. So they're really directed at the customer, but other people might be interested if you're looking at getting one of my looms. So we'll talk to you later. So this is the instruction video for installing the 1UZ UCF20 loom with auto transmission into the Daimler. So g'day Ken and Steve. This should be pretty straightforward, but I'll try and put as much info in here as I can so you know all the different options. I don't do many written ones because I can do a video far easier. So let's get into it. For a start, I am giving you back that mess, and along with the bag of old connectors and plugs and crap. So I'll give you that back. I'll bag that up as well, so that can go in there. I'm giving you a EFI temp sensor. They're a bit of a pain to fit. I've got a special socket that I use, which makes it much easier, but they're tucked down in behind, below the lead cover, the leads above the top coil. I'd like a new one fitted. I'm not spending this money to fix a loom and then relying on a 25-year-old sensor. 95. Yeah, not quite. 24 years. There's your start loom. So on that, I've just taped it up and I've put some new plugs on it. I've put a Raychem heat shrink going down to the knock sensors and a new connector plug for the starter. So that can go back on. That's easy. And in this box, in this bag, I've also supplied another coil plug because we don't do that's on the front start loom. I'll give you a copy of my hieroglyphics for the relay box and fuse box. So that is looking from the top. I've got my check connector here, which has that diagnostic plug on it, but I have modified the one on the engine. So this one has been modified. In the making of this video of this loom, I do show connecting into that with a normal scan tool, square plug or rectangle plug, and if you can't get in as an LS 400, go in as a generic Toyota or generic Lexus. Easy. Right, you had a fan switch, which I believe is mounted up in here. There is the fan switch wiring, a blue one and a brown one. And if you want oil pressure to run through the loom, just clip the hydraulic fan solenoid wiring, put a plug on it, run it to your oil pressure. And water temp wasn't connected, it had been converted to fan switch, but I do have a wire in there for that now. It's going to be this one, just tucked down. So it's that one tucked down. So if you do want to put a temperature switch, a temp gauge sender into the block in the standard position, it will come through to this black plug. So this black plug is labelled H2O for the water temp, check engine light, CEL for the check engine light, as a negative output for the dash if you want one. Tacho, black yellow in this case, for the tacho on the dash, and I've just done a video on tachos using your loom as a demo, which was handy. And oil, that's the one from the hydraulic fan switch, so that's been modified. There are two wires together, so if you do need a signal and an earth, then you can put two separates and just split them apart, pull that out of the plug. So that is your dash wiring in that one. Tuck that out of the way. This wiring plug here, it's got TE1, TE2 earth, ECTW and ENG. That is for the diagnostic adapter for me. You probably won't use it unless you can find a semicircle and I can make you an adapter. It did allow me to get transmission codes as well. This one with the green wires and the one red black marked PND, park neutral drive, R21 reverse, second and low. Pretty self-explanatory, you can handle that. Going into these plugs here, the Deutsch plugs, I have labelled what is going through each plug. So you'll just plug them in, real easy. The big start trigger is the on the single plug, so that's nice and simple. But the alternator wiring, so the alternator wiring went, I don't know where in the car. What I have done is I have added a ignition signal and a sense, both fused. That ignition signal there going to the alternator, I've also tapped into your other dash plug as ignition out, just in case you want to run power to switches like the overdrive switch, those sorts of things. So I've done that as well if you wanted. So this will allow you, if need be, to take the Deutsch plug and tap into the vehicle's wiring, or plug it into my loom, just power it up, and there's the ignition light, or the alternator light, over here, marked as L. So very straightforward. Relays and fuses, mount them wherever, and coming out of there is this blue wire, black plug. It's got fan written on it. So ditch the fan wiring, the fan relay that's presently in the vehicle, throw that away. That's your fan output. It's nice and big and grunty. So that should run 20 amps of fan, not a problem. And then this one coming out has a white plug, it's a red wire, and it's got fuel written on it. So that goes to the fuel pump. So that should be straightforward. These two I won't shrink. Okay, I'm not going to do the heat shrink. So if you want to cut them back shorter or whatever, you can. That's really easy. I'll let you sort that out. And I've put sleeving. I put a split sleeve on these trigger wires here. So if you do want to cut them off, put different plugs, whatever, you can do so. We have the MIDI fuse here. So in the fuse, I've got a 70 ampere and 100 amp. I'm presently running this setup without the fan on a 30 amp fuse, not a problem. I haven't actually checked how many amps is running through it. I might do that. So alternator fuse, it's a 100 amp alternator fuse, and a 70 amp for the fuse box. Again, I've got the wiring for the alternator. I've left it a little bit longer than we need, so you can cut it down. And I might try and remember, I thought I had one to give you another crimp terminal if you want to change that length, not a problem. So power that up, power both of those up, and that feeds power to the whole system. Transmission, plug that in, that's easy. Oh, we better do the main input power, main input wire. So we've got ignition switch positive. So that feeds the ignition switch positive into the loom. I've just been doing it on my fuse right here. And of course it does run, it's good. We've got the light, L for light for the alternator. STA, so that's a start input. Ignition out, so fused, same as the alternator. That will give you a safe power supply if you want to wire up some of this, the power, PWR, or the 3. So the 3, just put it on a switch, somewhere on the dash or by the shifter. By turning that on, by feeding 12 volts into that 3, so purple wire, it goes through a fuse, so it's all nice and safe. That will turn overdrive off. Okay, I'll repeat that. That will turn overdrive off, so you'll get 3 gears. PWR, again, it's a positive, so 12 volts, we'll put that into power mode for the transmission, and it'll kick down faster and hold gears a bit longer. ELS, electrical load signal. Again, it's a positive. If you want to put that in, you can tap into your lights, so tail lights or headlights. Generally, it's just on the park light circuit, and that will up the idle a little bit. Not strictly necessary, but I've put it in there anyway, just in case. And BK. BK is important. That is for your brake lights. So by putting that in, it wasn't in there before, there's probably no wire in the car. It is a 12 volt input when your foot is on the brake. That will allow the computer to shift it into first gear when you come to a stop sign. So when you come to a complete stop, from the speed sensor and the brake lights into first gear, so you're in first gear when you take off. So I hope that all makes sense in that area. In the loom coming off, I've left the plastics or the rubber boots on. Yes, I wired the whole thing through those rubber boots. Supplied a piece of split sleeve or conduit and some tape, so you can cut that to length and work that work. And then same as going into the cabin, that'll just need a bit of adjustment to suit your application. So you'll just need to a bit of tape in the appropriate places and zip ties appropriately. The ECU or the ECU plugs are now in the main loom, so nice and neat and tidy. As far as the loom goes, if you're not using the breather, the VSV for the fuel tank breather, you can just leave it off, it won't fault, tuck it in. Other things I want you to check, please, is that the injector seals haven't gone all hard and are all swelling out of the holes. That's really important. I see it a lot. This one's already had injector seals. And apart from that, it should be all pretty good. This one had new hose here and a new hose here. So it was all prepped lovely. Please make sure that the earths are nice and firm on the back of the block, there and there. I know they're a pain to get to, but that's quite important, of course. I have removed the TPS, the sub TPS. I've got a video on what I do there, and I run a tube through to the idle speed, or you can just blank them off. I like it for aesthetics, especially when you're trying to make a vehicle look really good. And please make sure that both your cam angle sensor plugs are in good order. I've got them. If you do need them, just give me a yell. You'll also see I've taken the water lines off the throttle body on this one. So that's blanked. No water lines in here, making it far easier to work on. My stepper motor has been working just fine. If your one hasn't been working because it wasn't powered up properly, so hopefully it is fine, and give it a few moments to warm up, go through a couple of cycles. Once you've got the loom on and fitted, if you fire up the vehicle, run it for about 20 seconds, you may have to hold some foot on the throttle and then turn it off. If you do that 3 or 4 times, it will reset the idle stepper to close, and then it'll tidy up over the next few days as it gets started and stopped a few more times. I think that's pretty much it. I'm going to lift the loom off. I might just show that real fast. I'll put it in fast mode, taking the loom off, putting it in a box for you. And let's fire it up one more time before we call it a day, before I pull it to bits. Power, fuel pump's connected, starter. So that motor's sounding much healthier now. So I'm happy about that, and your loom's working like it should. So I'm going to get it off and put it in a box. Yeah, so I'm not sure which one I prefer. This one does look a lot simpler. Pity it looks like it's done by a 3-year-old and would never run the engine properly. With the key off, no amps. 1 amp with just the ECU powered up. So revving it, I got up to 12 amps. If I disable it from starting and crank it, starter inhibit, the starter give it is 7 amps for the trigger. I need a bigger box. So I'm all done. It's in a box, ready to be sent off. So this job's done. And I'm on to the next one. We'll talk to you again. Catch you later.